talk is called WebXR for Cooperative Work, Thought, and Play. I'm going to tell you a little bit about what WebXR is. You may or may not have heard of it. And pretty quickly, I'm going to go into this somewhat of a tangent about where this technology came from and what it might mean, and how it reminds us of a lot of the work in the history of computers. So let's start with what is WebXR. WebXR is a browser API that allows web applications to connect to immersive devices like VR and AR headsets. It was preceded by a browser technology called WebVR, which was for virtual reality headsets. WebXR adds augmented reality headsets, and it also brings the 6th degree of freedom controllers that people are holding when they use these devices into the API as well. Importantly, WebXR is not a rendering API. It's not about displaying anything to these devices. For that, you use existing browser APIs like WebGL or WebGPU, which just shipped in Chrome beta last week. So what it really is just the ability to get where is the headset or the device in space, what direction is it facing, what are the timings you need to render to the device. So in some sense, there's not a lot I can say about WebXR that you can't find very quickly looking at the documentation. And so what I thought would make an interesting talk is to think about where WebXR came from, what is its legacy, and what could it mean for us as we try to bring people together online more and more. Okay. So for myself, I got started in virtual reality in 2013. I got one of these Oculus development kits, and for about $300. They had just done a successful Kickstarter, and they raised some absurd number. Well, absurd at the time, like $2.5 million when they were trying to raise $100,000 to just build some of these things. I got really excited about it because I had never seen computers do anything like this. You would screw in the lenses and you'd adjust the interpupillary distance and you'd strap it on, and you'd go on a roller coaster and you'd get sick and you'd want to go right back and do it again. Douglas Adams has this wonderful quote that says, anything that's in the world when you're born is normal and it's ordinary and it's just a natural part of the way things work. Anything that's invented between when you're 15 and 35 is new and exciting, and you can probably even make a career out of it. And anything invented after you're 35 is against the natural order of things. So for me, this was, wow, exciting, new. I could maybe even make a career out of this. And I assumed that this was only possible because Moore's law was in effect and computers were getting faster. And indeed they were. This tweet I love, it really sums up some of the progress that have been made. Early microcontrollers or personal computers, this is the ARM1 processor from 1985, had 25,000 transistors, and in 2021, the M1 ARM processor had 10 cores and had 57 billion transistors on it and was only modestly bigger than the ARM1. And so this is a hilarious tweet. And started here is a little misleading because this wasn't the start of computing. It was the start of like kind of microcontrollers and personal computers. But VR actually goes way back before that. Here's a paper in 1968 by Ivan Sutherland where he and his team mock up this virtual reality display. And there's this long linkage that measures your hedge tracking. And they got the whole pipeline right. There's a computer program, there's a view that you're going to have to multiply all of the 3D world by, and eventually you're going to have to raster that to a display, and they got a little mini cathode ray tube affixed to the side of your head. And so they did all this work, and this wasn't just, in theory, this wasn't just the math. Like, they built this thing. It looks like this. I was kind of skimming the paper and preparing for this talk, and something that jumped out at me was in the acknowledgement section. The first thing he said was, when I started working on it, I had no idea how much effort would be involved. And I relate to this. It's actually quite difficult to build these systems, and I'm only working on the software side. They had to work on the hardware as well. So, even though I didn't know about it, virtual reality had been alive in the dreams of developers, and The dream was alive in the 80s and 90s with a company called VPL, led by a person named Jaron Lanier. And they also, in addition to the headset, wanted to bring hands into play. They had these full body suits, and they really wanted to transport your consciousness to another realm where you could more wholly express yourself. You weren't sort of confined to your meat space avatars. You could explore other realities. So the head of this group, VPL, is named Jaron Lanier. He's remained an influential figure in the space. These are some of his books. I just want to take a moment to appreciate him because he's one of those thinkers who really challenges the everything's great, isn't tech wonderful narrative that is familiar to us. He's encouraged people and argued for reasons why you may consider deleting your social media accounts. And he's someone who's very good, I'd say, at seeing the forest keeping the forest from the trees. And he reminds me in a lot of ways of Marshall McLuhan of 50 years earlier, who coined the phrase, "The medium is the message." And when McLuhan was working, he was looking at media from a critical perspective, saying, not just what's the content of this media, but how does it change our behavior? How does it affect how we think and how we play and how we get together? He distinguished between hot media, things that don't require you to participate. So watching a movie, it engages one of your senses. You can just sit there and it heats you up. Versus cold media, like reading a book, you have to be a lot more active. You have to use your imagination. You may have to track back and forward through a text document to really pull the value out of it. He was also famous for a couple phrases that we're familiar with today, like, well, I already talked about the medium as the message. Another one was the global village, the idea that in an age where more and more of our media can be mass produced and then mass consumed, each person's influence and sphere of connection was going to get larger and larger to encompass the earth. And unlike what people might assume about this time, McLuhan didn't assume this was a good thing. He wasn't saying global village, like, this is going to be peace and love and we're all going to sit around a campfire. In fact, the opposite. He expected that the wider our reach becomes, the more divisive and the more arguments that we're going to meet, because of course we're going to have more diversity of thought and more people interacting with things. And so he kind of anticipated some of the problems we see in today's world with social media, where you can tweet and anyone around the world can take issue with what you've just said. So I'm going to keep talking about this stuff for a while, but I want to quickly say that this is not a talk about the metaverse. The metaverse hype cycle has come and it's gone, and I don't know what it's going to go. I think the crypto community has sort of co-opted it and is really excited about it. There's an amazing video that came out just a couple weeks ago dissecting this hype around the metaverse, and I'm going to read you a pretty lengthy quote that summarizes some of the feelings I share about this vision of the future. So this is a video by Dan Olson, an Alberta-based documentarian. He's talking about how, at this point in the video, about how lots of the successful applications in the space, like Minecraft or Roblox, people who like metaverse like to claim them as their own. Like, yeah, this is like a precursor to the true metaverse. And any failure in the space, they're saying, oh yeah, that's not the real metaverse. That one was just a fluke. So he says, this flexibility that allows for anything good and popular to be a part of the natural, inevitable precursor to the true metaverse simultaneously provides the flexibility to dismiss any failure as a failure of the pure vision, rather than a failure of the underlying ideas themselves. In other words, the metaverse can't fail. You can only fail to make the metaverse. But there's no consensus definition because the metaverse isn't real. It's not an actual thing anyone's building. It's a rhetorical device that allows the writer to gesture at the future and pontificate about what ought to be. Definitions of the metaverse are thus principally rooted in the writer's present political and social values. When you understand that the metaverse isn't a distinct invention or construct, but merely a rhetorical proxy for the future of technology, then all of the conversations about it become easier to deal with. Most advocates of the metaverse maybe haven't considered whether achieving this goal is any good. They just take that part of it as a given because it's always super cool in stories, and why even bother considering the fact that the end result, if we achieve it, might be boring and inconvenient and disappointing. So that's a bit of a downer. I just want to make clear that I'm not trying to hype up this fictional metaverse space, but I do think that these immersive devices are going to really impact positively the way that we can get together. But before we get there, I want to talk about something called computer-supported cooperative work, or computer-supported, gosh, I'm forgetting now that all of the variants on this name, computer-supported collaborative work, or I'm personally a fan of the term groupware. This roughly points to the way that we use computers to talk with one another, to work together. And if you look into the space, you'll quickly find graphs like this, or matrices like this, where you're looking at, well, we can get together at the same time as one another, or we can get together at a different time as from each other and communicate asynchronously. We can be co-located in space or differently located in space. And of course, if you're talking about virtual reality, you need to add a little bit more dimensions to this, where you could be in a different physical location in the same virtual location. So this is a graph, or a matrix from, I think, the 80s. And since then, people who study this stuff have broken it down way further and tried to classify the ways that we get together and the strengths and weaknesses of each medium. One of the exciting projects happening now in the same time, same place dimension is called Dynamic Land. So Dynamic Land is a project started by Brett Victor in Oakland, California, where the fundamental idea is that rather than having a human standing in front of the computer device and interacting through the device, why don't we have the device surrounding the humans? Like the whole, he has this phrase, the computer of the future isn't a product, it's a place. And the idea is, in Dynamic Land, you go into a place that has been augmented by cameras in the room and by physical objects that are programs, and you can explore this together. This comes from some observations Brett made about the way people learn from each other, and how there's a long history of, yes, we've got great online courseware, but most people drop out of those courses. They don't complete them. And some of the technology for learning new thoughts and thinking new thoughts is passed only through face-to-face interaction with people. So Feynman diagrams are a technique for understanding quantum physics, and it's named after Richard Feynman. And it turns out that for several years after he invented this powerful technique for understanding new science, even though he was publishing the diagrams, the only people who really understood how to use them and started applying them to their own work were people he physically was in the room with, teaching them how to use it. And this idea of teaching people face-to-face and using our bodies and embedded knowledge comes up again and again if you look at the history of technology and science. There's a quote by Einstein, I didn't pull it out for this, which is about his physical intuition when thinking about light and when thinking about time. So this is a slide pulled from a talk by Brett Victor called The Humane Representation of Thought, where he explores the capabilities of a human person and then looks at different media and thinks, well, are we using these superpowers? These are things that we didn't invent in the last 100 years. These are things that we got from thousands or millennia of evolution. So if we can co-opt these capabilities when coming up with thinking devices, computing technology, cooperative software, that's pretty good. And he thinks about the visual a lot in this talk, and he points out many examples of things that we might not consider technology, but they actually allowed us to think thoughts previously unthinkable. I'll just take a couple examples before moving on, but I highly recommend you watch this talk. I'm just shamelessly ripping it out from his talk. So this one in the bottom row that says x squared plus 10x equals 39, this is symbolic algebra. You can instead write this as a sentence, which is, what is the quantity that when squared and added 10 to itself is equal to the quantity 39? And when you're doing complicated mathematics and writing it in sentences, it's really hard to hold everything in your head. This is something that we can teach grade school students, and they get it pretty quickly, as long as they repeat themselves. So some other ideas were place value digits, Arabic numerals, where once you get to a certain count, like 10 for base 10, you just shift over the digits, and then you can intuitively get a feel for how large of the quantities you're dealing with are. This beats out Roman numerals and things like this, which makes it a lot harder to think about arithmetic. In fact, that you needed things like abacuses to do arithmetic in the Roman Empire, I think, don't quote me on that, because it was so difficult to do arithmetic with Roman numerals. There are some other great examples here, but I'm not going to have enough time to get through the talk if I go through all of them. Highly recommend watching this. And also I want to mention that this is a not-for-profit. I think this Dynamic Land is probably the most exciting project that I know about in the field of computers. And so we're all technologists here. If you work for a company that makes charitable donations, I'm in no way affiliated with Dynamic Land, but consider them for your next round of donations. I think they're doing great work, and I would love to see this become the reality. Okay, so let's get back to people using these symbols and technology to communicate with each other. Another person who cared a lot about symbols was Doug Engelbart. So Doug Engelbart is famous for inventing the computer mouse and corded keyboards and input devices like this, but his influence went much deeper than that. He had a lab called SRI and the Augmented Research Center. He was very active in the 1960s, and he focused all of his work on the idea that the problems that we're facing in society are getting increasingly complex. And we need ways to rise to that complexity. We need to boost our collective IQ. And so his whole mission was to use computers to make people smarter together. And this was in contrast to the time of another popular way to think about what computers can do, which was AI. That we don't need to be smarter, we need to build a system that is as smart or smarter than us, and then we can just offload the mental work to the system. Now, this debate was raging for a long time, and they both kind of simultaneously developed, and it's still relevant today. Do you need to get smarter, or does Copilot need to get smarter? I'm not sure. And I'm not really going to try to argue with it. I just want to point out a couple of ideas that came out of Doug Engelbart's work that is very relevant to how we get together online today and how we try to do cooperative work. So the first is something called a dynamic knowledge repository. This was, think about it as Google Docs plus your wiki plus Git. It was the collection of knowledge that your organization needed to make decisions and a history of those decisions. Another key idea was an open hyperdocument system. So information in computers doesn't have to be linear. It doesn't need to be a book. It can be linked together and indexed and searched. And the last idea is something that he termed a networked improvement community. This was a group of people who wanted to get better together. And what they were going to do is they were going to build a tool that allowed them to get better. And that once they were better, they would build a tool that allowed them to get even better. And then once they were even better, they could build a tool that make them even better. This idea was called bootstrapping, and he advocated for technology companies to split into the groups of builders and the people who are watching the builders and figuring out if they're getting better at building. So sociologists and xenographers, I don't know that term, psychologists were a fundamental part of research organizations in the future of envisioned by Doug Engelbart. And so this is the 60s, and just to couch this in what else was going on, this was only 15 years after the Memex was dreamt up by Vannevar Bush. So this was a device that was not built till way later, and what it allowed you to do was have two screens built into your desk and a control panel to your right, and as you were reading one document, you could search for related information in another book or another document and see it left and right. And okay, this is pretty unimpressive to us today, but again, thinking about the time that this was in 1945, we didn't have general purpose stored instruction computers. One was being developed, actually several were being developed. This one was called the Electronic Numerical Integrator and Computer. And it was one of the first electronic computers. And I say that because in those times when you needed to run calculations for example, figure out trajectories of ballistic missiles in war, you needed humans to do computation. Those humans were called computers. So an electronic computer was able to do that hopefully faster and more reliably without error. The ENIAC was developed by a team led by or visited by von Neumann, who was at the height of his fame. He was kind of a superstar in the research era. He was part of the Manhattan Project. And so the ENIAC, which was originally funded for this ballistics calculation, ended up doing a lot of calculation for the atomic bomb. And so I mentioned this idea of a stored program computer. Programming the ENIAC meant taking those wires and reconfiguring them. It wasn't writing machine instructions. The idea of storing instructions as data had come out 10 years earlier with Alan Turing's paper, but it was a mathematical concept. It wasn't a real thing. There was nobody writing code that a computer would read for some time. So it was not even a stored program computer. Data and process were completely separate. But we did get out of this the idea of the von Neumann architecture, which should look familiar because all computers are like this today. You've got a central processing unit, you've got some input coming in, it talks to a memory unit, you've got a logic unit for computation, and you output something on the other end. So this is Grace Hopper in the 1950s. And just to drive the point home, Grace Hopper invented the first compiler, or we might call it a linker today. She was advocating in the early 50s that people don't understand computers. We should write computer code in English languages and then compile it down to machine instructions now that they did have stored instruction computers, stored program computers. And if you look back, people were like, that's ridiculous. Computers only know numbers. Why would we have them learn English words? That's pretty silly. But she had the experience of trying to sell to upper admirals and generals of the Navy projects that would help their ships and commanders make better decisions in real time in the field. And they were not about to learn binary computer instructions or anything like that. So I could go on and on about this, and if this interests you and you know more than I do, or anything, and you want to talk about it, please come talk to me after the talk. I have to get back to the main thought line of the talk. So if you want more, these are two books that I highly recommend, The Dream Machine on the left and Bootstrapping on the right. And these are interesting because they're very personal computer history books, meaning they tell you not just about the technology, but who were the people working on the technology, what problems were they trying to solve, what were the personalities and the personality conflicts of the people working on this stuff. Okay, so people have been working on computer-supported cooperative work for a long time. So it's solved by now. We know how to do it, right? Well, not exactly. Despite all of that history and dreams about how people are going to use computers, the state of the art that we fell back to when everyone went home for the pandemic was Zoom. We have video calls, we have shared media, we have slides and things like this. We don't have two or many mouse pointers in the same simulated space. We don't have a number of things that they envision for the future. And I'm very critical of video calls because I think that getting together online can be much better. And I'll tell you why. I think Zoom is good for some things, but they're bad for groups. So a video call is bad for groups because when you're on a video call, you can have one person talking at a time, and everyone can look at one piece of media or visual aid at a time. When you make a gesture on a video call, you're broadcasting that gesture to everyone. It's very different than when we go in the hallway at this conference. There are 50 or 100 simultaneous conversations going on. You can float seamlessly between them. There's the audio in the real world has physics physical qualities that make it so that things far away are quieter to you, they don't interrupt you, but you can be close enough to a conversation that's interesting that you can seamlessly transition from one to another. And for this type of group socialization to work well, we don't have to recreate everything about being in the real space as each other. We just need a few key aspects. We need to be able to non-verbally give body language that signals where our interest is going, what we're thinking about, whether we're confused, whether we're queuing to speak. And we need to be able to arrange ourselves in some fashion where we can do that seamless transition from conversation to conversation. This doesn't look like how we get together online today. And so in some sense, the vision for this has failed so far. I want to talk about another vision that has failed so far. This is software called Compendium. It was meant to solve so-called wicked problems. So wicked problems aren't evil problems. They're just problems that resist solutions. Think about policy. Think about what decisions to make as a company leader, things that you need lots of data and you're making a lot of assumptions and it's not clear where to go next. Often you want to have debates and you want each debate to be able to present their full argument before just making a decision. And once you make a decision, you want to be able to refer somebody who wasn't a part of that discussion. This is why we made that decision. These were the ideas, the supporting evidence, the arguments for and against. And if you ever change that decision, if you've ever onboarded someone new to a company or a new project, you know they're like, why any of this? Why did we build it this way? And often that historical context is lost. And so Compendium and this book Dialogue Mapping was both software and social norms for building this dynamic knowledge repository that would solve these problems better. And what they found was disappointingly for them, I'm going to read a quote from one of the people building this. Many of the attendees of our training workshops, despite their initial enthusiasm, fell prey to the same pattern we'd seen in the beginning. They try the approach in a meeting or two, fall behind, or otherwise get stuck and give up. This experience seemed to be in accord with many of the reports in the '96 Moran and Carroll book, as well as other early work in hypertext and design rationale approaches, which emphasizes the cognitive overhead involved in creating representations of design rationale. Many of these researchers seem to despair that the difficulties would not be overcome. So these are not people who were forced to use this tool. Even the people who wanted to use this tool and improve decision-making couldn't adopt it successfully. And I want to think about why that is. You could look at this and say, well, because look at it. This isn't software I want to use. It's clunky. How do I navigate anything? This seems like a big overhead. And you know, for this particular software, maybe that's true. Although at the time, this looked like a lot of other software that had come out. I think that there's a different underlying pattern going on that we can see in a lot of other places that is summed up by the phrase worse is better. So worse is better is also called the New Jersey style in contrast to the MIT or West Coast style. And it's coined by somebody named, Richard Gabriel, who was writing about the Lisp language and why it was so sticky, why people were able to take Lisp and customize it to their needs. And the argument goes like this. Building something the right way is really difficult. It takes a lot of time and effort. And even though the right way leads to the best results, it'll always lose in the market to something done the wrong way, solving the problem as kind of a kludge. And so a worse product for the user is better at surviving. And so, so the idea of worse is better, and I won't go into why it's called the New Jersey style, the MIT, Stanford style. It has to do with what technology companies were building at the time and the way they tended to do it. But I do want to look at some other examples of this worse is better in action. The first example that I can think of is Unix and Multics. So Multics was an operating system that was somewhat ahead of its time. Planning started in 1964, and development continued for years and years, and Bell Labs ended up pulling out of the project in 1969. But before that, Multics had achieved a lot of the capabilities that you wanted from a mainframe computer that was going to be time shared. So time sharing was sort of a novel concept. It was not well supported by industry veterans. Like IBM was notoriously slow to adopt time sharing, and the Multics operating system had time sharing. It had okay, I'm not going to be able to find the list of things in my notes. Suffice it to say, Multics was a complex, very powerful operating system for its time. And then a few people who had worked on Multics broke off and at Bell Labs wrote a way simpler operating system that had like almost none of the same features called Unix. And Unix was so simple that they got it up and running very quickly. And at the time, there were so many different computer hardware that that an operating system wouldn't have to support, that Unix was small enough that independent people could go and port it to their system. So the Homebrew Computer Club, people who would go and build their own homebrew computers would be able to port Unix to their device. So Unix ended up being way more successful than Multics by many orders of magnitude, leading to Linux, which of course powers like, I don't know how much percent, a huge percentage of all computers today. And if you're its descendants and its variants are running our smartphones and our servers and all that. The next example I want to talk about is the World Wide Web in contrast to something called Project Xanadu. So the World Wide Web is the web as we know it today, and I'll get to that. But many people are not familiar with Project Xanadu. So Xanadu was invented by Ted Nelson and a few people around in his circle. And the idea was, first of all, it came 30 years before the web. He was talking about these ideas in 1965. And Xanadu was a hyper document and hyper media system that was going to solve a ton of problems. It was going to index and link information from research papers and books. It was going to allow people to publish any kind of media from video to audio to text to interactive computer programs. It anticipated some of the problems that we have with the modern web, where Jaron Lanier has this term siren servers, which means it's a server that calls out to you like a siren because it's so valuable. And it's valuable because it's collected all this user data and hosted it for you and become this wonderful resource. And the reason it's a siren is dangerous is because it doesn't compensate you proportionally to the value you've added to that product. So if you think about YouTube as an example of a siren server, well, you can make money making YouTube videos, but your income is determined by whatever algorithm the server administrators decide. And that can fluctuate with their business model, and you can get demonetized, or you can not have your video show up as often as you'd like, and things like this. So you're kind of, you're buying into this situation where you have less power. So Xanadu had transactions built in from the start. And the idea was that if you added value to the network by writing something people wanted to read, you could charge them some amount of money every time they fetched that data and they read that data, or they included or transcluded that data on the internet. And I'm not going to spend too much more time on this, but it's worth perusing the 17 original rules of Xanadu. I just had it fall off the edge of the screen because there are many. Every user was going to be securely and uniquely identified. You could upload any data type. Documents would contain royalty mechanisms, so that anytime somebody used your work, you would get compensated for it, and there'd be secure access controls on all of these documents. So this was like a wonderful vision. It didn't really come to fruition, and it took them a long time to build any even prototypes and release those. But they were pretty upset, this group, when the World Wide Web came out and started taking hold. So the World Wide Web is a much simpler system. It was Tim Berners-Lee at CERN looking at all the documentations that CERN and data CERN was producing and saying, we need a way to index this. We need a way to share this across all the computers in Europe and associated with CERNs and research institutions. So let's invent a system that I can put a document somewhere at a unique URL, at a unique identifier. I can get the document back. I can update the document, I can delete the document, and that's HTTP. And then what are these documents? Well, let's write it in a format called hypertext document language, or hypertext markup language. And that way you can add some amount of context to the document to give it structure. So this is the title of my document. Here's a level 1 header. Here's a level 2 header. Here's a table. Here's a unordered list or an ordered list. And so the World Wide Web solved that problem really well, and it didn't solve any other problems. You couldn't have images in the original versions of the web. And this simplicity meant that anybody could write clients interacting with web servers. Anyone could write web servers to interact with clients. You could join the network just by broadcasting, hey, like at this IP address, you can find me, or it's not always IP. Some of these were intra networks that were pre-IP adoption. And anyway, so this was the World Wide Web, and then the World Wide Web evolved over time. It was worse than Xanadu, but it was better at survival. So the last example of worse is better is I'm going to take from Grace Hopper. So Grace Hopper gave this great talk in the 80s about, well, where she saw computers back then, where she thought they were going. She told this story of being a child in New York City, and she would sit on the stoop and watch horses and carriages walk by. I don't remember what time it was, so I'm going to say something in the 1910s, 20s, but I forget. And across the whole day, she might see 1 or 2 cars, because cars were enormously expensive. They were custom built. Every part in it was unique to the car. And there were no garages, so if your car broke down, you would you would send a telegraph to the manufacturer and say, hey, my car broke down here. Will you please send a man out to come fix it? A repairman would come out within a week or 2 and look at what's wrong with your car and custom fasten a part to fix it, and then you would get back on the road. Well, on the dirt path, to be honest. And then along came Henry Ford, and Henry Ford had 2 ideas. Standard interchangeable parts and an assembly line for manufacturing cars. And pretty soon, General Motors was selling Model Ts for a few $100s, and Americans started to own cars. And once they owned cars, they needed roads, so they built the roads, and they needed garages, so garages would stock these interchangeable parts and be able to fix cars when they broke down. And we saw gas stations because you wanted to be able to fill up, just drive your car up, and rather than go and fetch gas and put it in your trunk and drive around with it that way. And so the Model T totally revolutionized transportation in the country. But her complaint was that in the 80s, she didn't think that people thought about or solved the problem of transportation as a whole. Railroads at the time were in disarray. The Army was manufacturing equipment in the middle of the country that they literally couldn't ship to the coasts where they were going to put it on tankers and ship it worldwide because there wasn't the infrastructure built. And her point was that we focus singularly on this incremental step of cars, but we failed to look at the bigger picture. And she was worried that with computers, we would be ever more enchanted by the blinking lights and the convoluted software without looking at the underlying thing, which she thought was the total flow of information through any company, organization, what have you. And I think that's sort of the point I'm trying to get at, is that worse is better is how a lot of software just exists in the day. We have to accept it if we're going to build something that stands the test of time. But it doesn't necessarily mean that we're going to get the outcomes we wanted. So are we doomed to forever use video calls, which I think are an inferior medium for socializing and getting together online? Hopefully not. A lot of the work that I've done so far is pursuing some way to break out of this. But what I found is, just like Ivan Sutherland, it's a lot more effort than I anticipated. So this is an iceberg, and this is a metaphor for anything above the iceberg is visible. We know about this. This is what we expect. Anything below the water level is the unexpected, and it's much larger than what's on top of the iceberg. For game development, this is the top of the iceberg is the unique game that you wanted to make, and underneath the iceberg was all of the other stuff you needed to learn and implement and build and maintain, like graphics, networking, input audio, etc., in order to build the unique experience that you wanted. There are great programs on the market today like Unreal Engine or Unity, which are general purpose game engines that push a lot of those necessary parts of game development underneath the waterline of the iceberg. But they're still, because they're general purpose, and because they're very powerful, they leave so much on top of the iceberg. So if you wanted to make an immersive application with multiple people talking in a space, that would still be very difficult to do with Unreal or Unity starting from scratch. There's another way to make game engines, which is to build them fit to purpose. So here are screenshots from RPG Maker. It's a game development tool for building a type of role-playing game inspired by Japanese RPGs. And if your idea of the game that you want to make is like an RPG, you should not build with Unity or Unreal. You should start with a tool that's made for making those kind of games, because you'll spend a lot more of your time building the application you actually wanted. There's another one I wanted to mention here, but I don't have screenshots, Monogatari, which is for building interactive visual novels, a kind of interactive fiction. People like to build with Monogatari. And my point is that if you want to explore a particular type of experience, you should find a tool that lets you build it. And that's what a lot of the work that I work on is with Hubs. So Hubs is, in some sense, a social experiences engine. It leaves a lot of the high level, tip of the iceberg, what you want to do in virtual spaces to you, and it delivers two capabilities that I think are key for having the kind of social experience we have in the hallway. The first is social presence. Social presence is the idea that when you're in a virtual environment with somebody else, you want to feel like they're there. You want to get their body language. You want to know when they're nodding along because they're understanding what you're saying. You want to know when they cock their head to the side because they're a little confused. You want to know when they're queuing to speak. Social presence requires like low latency and capturing some amount of body language. Spatial audio, which emulates the physics of audio through space, so that as you're moving through these virtual environments, the things around you are loud and the things far away from you are quiet. And also like left, right, and front to back and up, down panning. If you ever want to get really interested in audio, look at head relative transform functions, or HRTFs. Audio engineers build these models for simulating not just how audio moves around the space, but how differently shaped heads and ears will hear those sounds. And so like the PlayStation 5 has a dedicated audio engine, and you can program games to accept these head-related transform functions. You can go to places that will measure your head and the shape of your ears, and then give you a file that says, okay, use this when you're playing games, because things are going to sound better to you. And so the second capability that Hubs offers on top of just the graphics and rendering and networking is shared media. The idea that when I'm talking to somebody, I want to be able to reference an image, a video, a website, and I don't want to just send them a link. I want to pull it up and show them things. And so you can do this with Hubs. So coming back to the game development iceberg, for Hubs, the unique social experience, whether it's cooperative work, or socializing, the conference, museum tours, classroom experiences, the activities you want to do and the custom code you want to enable sit on top, and everything else that enables that experience is either at or below the waterline. So you can swap out your own avatars and environments, or you can pull some from the internet. We host some that you can use, but it's really not the point. It's meant to be a very small, thin layer that can stand the test of time, and you can run this yourself. So this isn't the same as one of these metaverse platforms where you come in and you make an account with us and it goes from there. This is server software. You run it yourself. You host it on your own domain. Your users can access your application in their browser. You send them a link and then they're in. Compared to developing on Unity and Unreal and trying to get users to download and install your application, distributing something in the browser is much easier. And it also, for certain platforms, is necessary, because if you want to do microtransactions or have a financial relationship with your users, that on mobile phones especially, but other places too, you often have to go through an app store, which is going to increase the cost by 30% because you've got to cover app store fees. So this is what Hubs is in a nutshell. People are using it for a variety of reasons. They're hosting events, they're creating art galleries, they are making virtual field trips, kind of like magic school bus field trips in this medium. And there's a lot of experimentation happening. And well, I can go into more use cases if that's what's interesting, but I think I'm going to just end here, say thank you for listening. Thank you for your time.